Hi everyone, Ms. Wissman here with a quick video lesson on rotational symmetry. So at the top of our screen we have our definition. Rotational symmetry exists when a figure can be rotated about its center and still look the same. So I've got three options here and we're just going to determine if they have rotational symmetry or not. So looking at this flower right here, rotational symmetry means I can take it and I can rotate it, and eventually it's going to line up and look exactly the same, like I hadn't moved it. Okay, so I can rotate it and it'll look like nothing's changed. Same thing with this one. I can rotate it and it'll look like nothing's changed, right? I can rotate it and it will line back up again, okay? So this one has rotational symmetry. I know it's kind of off there a little bit, but it's got rotational symmetry, okay? Let's look at this kite. I'm going to start rotating it. Not the same. Still not looking the same. Not the same. It doesn't look the same until I get back to where I started. So this figure does not have rotational symmetry. I can't rotate it and it lines back up with itself until I went all the way around. So it doesn't have rotational symmetry. A type of question you could get asked is, well, what's the smallest number of degrees you need to rotate it before it looks the same? So to figure out the smallest degree I could rotate it, I need to count how many times it takes me to go all the way around. So if I start with this petal and I rotate it to this petal, that's one turn. If I go from this petal to this petal, that's 2 turns, 3 turns, 4 turns, 5 turns. So it takes me 5 turns to get back where I started. And I can stop at each of those places and it'll look exactly the same, okay? But how many degrees is each of these turns? That's what my question's asking me, the smallest number of degrees. Well, if I'm going to go in a complete circle, that's 360 degrees. And if I divide that into each of those 5 turns I just took, I'm going to get the smallest number of degrees it takes to go from one flower petal to the next. So 360 divided by 5 is 72 degrees. So each of these is 72 degrees. That's the smallest number of degrees it's going to take for it to look exactly like it started. So take a look at this next one. You can go from here to here. So that's 1, 2, 3, 4, 5, 6 turns. So when I take my 360, I'm going to divide it by 6 because this took me 6 turns, and that gives me 60 degrees. So each of these turns was 60 degrees. In the next slide, you'll be asked to figure out the smallest number of degrees for each of them, whether they have rotational symmetry or not. And in one of your IXLs, you'll be asked to determine if it has rotational symmetry and the smallest number of degrees.